Hi guys. So I thought I'd give you guys a couple hints on this work because I realize it's a little challenging. So hopefully some of you don't need it and you're good to go, and others of you are like, I just need a little bit of help. So I'm gonna give you a little bit of help. I know you need it. Well, I don't know you need it, but like you can use it if you need it. Okay. So the conservation of mechanical energy. I give you some equations up here that we're gonna use. Okay. So here we have a 100 kilogram person is going to jump onto the wooden board and cause this 25 kilogram person to shoot upwards. You can consider the two individuals to be a system. So I asked for the initial mechanical energy of the system. So mechanical energy equals Ke plus GPE in this case, PE, but it's GPE because gravitational potential energy. Okay, so here's where we have to think about, if you think about these two individuals as a whole. So mechanical energy equals Ke plus GPE. So Ke, okay, that's where you have a velocity. And initially here, no one's moving, so there is 0 joules of Ke in this system. Okay. Now GPE depends on how high someone is in comparison to a origin point or to the ground. Now there is GPE, and there's one person that is contributing to the GPE of the system, and the other person is not. So we have this 100 kilogram man who is 4 meters high, and we have a 25 kilogram person. I don't know if it's a man, whatever. 100 kilogram person who's 4 meters high, and a 25 kilogram person who is at ground level. So GPE, there's only one person that is contributing anything to the GPE of this system, and that is our 100 kilogram person. So GPE is mgh. Okay. So you should now be able to find the mechanical energy. Okay. Because the only person that is contributing anything to our GPE is our 100 kilogram man. So I'm going to go ahead and let you do that. And you should get mechanical energy. The answer is between 3,500 and 4,500 joules. So hopefully you'll find that. Okay, now, okay, the person jumps and hits the board. Okay, and then what's going to happen is they hit the board, and all of that gravitational potential energy they had at the top, excuse me, guys, just ate lunch. All of that gravitational potential energy that 100 kilogram person had is going to become kinetic energy. And as they hit the wooden board, it's going to be transferred to our 25 kilogram person. So all of that mechanical energy that was originally had is now transferred over to our person, our 25 kilogram person, and part of it is kinetic energy and part of it is gravitational potential energy because they are starting to shoot up. So we have to think about the idea that Ke initial plus GPE initial equals Ke final plus GPE, whoops, want to print anything out? Plus GPE final. Nope, don't want to find anything. Okay, I'm not going to put these little subscripts on anymore. Okay, now here's the thing. Ke initial and GPE initial is just mechanical energy, which I found above. I found the mechanical energy of the system above. That can't change. So really the mechanical energy of whatever answer I had to A is going to equal my Ke plus my GPE of the guy, the little 25 kilogram guy as he's going up. Now here's the thing. I want you to tell me the Ke and the GPE. Now, that original mechanical energy of the system, which you found in A, is going to be split between Ke and GPE of this 25 kilogram guy. Now, I have no velocity. Okay, so I cannot calculate Ke. However, I do have a mass and a height. That means that I can calculate GPE because that is mass times gravity times height. So using that, You know what your mechanical energy of the system is, since this is the conserved part. Okay. You found that in A. That is going to equal your KE plus whatever you calculate for MGH. So you'll have GPE, which is part of the problem. Okay. And then to find KE, you just have to take the portion of that mechanical energy that is gravitational potential energy and subtract it from your total mechanical energy to get your kinetic energy. So you will have two answers here. So you should be able to figure that out. All right, now, next one. How high will the 25 kilogram person go? Okay, well, realize this. Okay, their highest point, oops, my goodness, did not want to get rid of that. Okay, the highest point that person will reach is equals the point where all the mechanical energy is GPE. So there's no KE because their velocity is going to be zero because they're at their highest point, which is where all of the mechanical energy is gravitational potential energy. So you found mechanical energy in A. Okay. Okay, so that mechanical energy in A, okay, is going to equal the gravitational potential energy that that person has at their highest point. Okay. So therefore, okay, you'll be able to do that mechanical energy of the system is going to equal the mass times the gravity times the height, which is what you got to find for the 25 kilogram person. Now, you know the mass of the 25 kilogram person. You know G, which is going to be 10 meters per second squared. You know the mechanical energy of the system, which you found in A, can't change. So you just need to figure out height. Now, D is very simple. Let me just say this. Mechanical energy is conserved. Your initial and your final mechanical energy have to be the same. So let me just use this equation. Oh, I don't actually have it in there. Oh, my bad. But mechanical energy initial is equal to mechanical energy final. Ah, subscripts are my issue. I don't know how I just found all this, but anyway. F. So if you already know your mechanical energy initial, you'll know all your mechanical energy final. Doesn't change. You don't even have to do a calculation. All right. So let's go on down to number 2. Okay. In this diagram, you have over here, you have ball A, which is 1 kilogram. They're thrown up in the air with a velocity of 10 meters per second. I want you to tell me what the mechanical energy of ball A is initially. Now, you have to look at the picture to figure it out because ball A has a velocity going upward, but they also are at a height above the ground. So the mechanical energy, oh, keep doing that. Okay. Nope, nope. Okay. The mechanical energy is equal to the kinetic energy plus the GPE initial. So ME is equal to the mechanical energy, or mechanical energy is equal to kinetic energy. Well, I can figure out kinetic energy because I know I have a velocity and I have a mass. Plus, I can also figure out GPE because I have MGH. I have a mass. I know G is 10 meters per second squared because I'm going to round it up from 9.8. And I know the height, which is 10 meters. So you should be able to find the mechanical energy that way. Now, how high will ball A go? Okay. Well, to find how high ball A is going to go, okay, what you need to do is figure out at its highest point, just like our other one, okay, at the highest point, okay, all the ME, all the mechanical energy, or all the energy, because mechanical energy is sum of both, is GPE. So whatever you find for A, okay, whatever your answer is for A, ME equals GPE. So ME equals MGH at its highest point. So you know M, you're going to know G, you just need to figure out H. So you found the mechanical energy of the system in number 2A, in A. So now you're going to have to find the height if all that mechanical energy is gravitational potential energy. Now, what's the KE of ball A when it hits the ground? So this one is also easy because when it hits the ground, that means it has no more GPE. All the GPE has been converted into kinetic energy. So, okay, what you can do in this case is, okay, all mechanical energy is equal to kinetic energy at let's see, right before it hits the ground. Now, why do I always say right before it hits the ground? Because when it hits the ground, that means that a force has acted on it. So we don't want to talk about that part. Okay. So mechanical energy, you found the total in 2A. So now it all has to equal KE. So ME equals 1 half MV squared. And if you look up, you can use this equation for velocity, which is velocity equals, so you have to solve for using the equation above, or just go ahead and solve for it using the equation for kinetic energy. And that will tell you oh, actually that's just oh, you know what? I actually went too far. So that's going to tell you the kinetic energy. And then, sorry, for the next question, which is really how fast it's going, you're going to solve for velocity using the equation above, okay, using the kinetic energy from C. Okay. So that's how you do those first two problems. So then let me talk about the next problems. Now, this one is where you actually have work involved. So work is involved in this case. Now, I'm not giving you the answers to these problems, I just give you some hints. Okay, so in this question, we have an 8-kilogram box that was initially having a velocity of 10 meters per second, and then a rocket applies another force for 4 meters. What's the amount of work done in the system? Well, this is super duper easy. I'm just going to give you an equation. Work equals F times D. Figure that one out. Okay. Now, so what's the final kinetic energy of the system? Well, I'm going to just give the equation you have to use. So kinetic energy initial, okay, plus the work that was done in the system equals kinetic energy final. Now, how do you find kinetic energy initial? Well, just remember that kinetic energy is equal, kinetic energy initial is going to be equal to 1 half mv squared. So I'm just going to go ahead and put that up. So first, you're going to have to find the initial kinetic energy, and then you're going to have to use that initial kinetic energy to figure out, plus the work that you already calculated in A, to figure out what's the final kinetic energy. And then using that final kinetic energy to use, this is just like the problems we did in class, use the equation for velocity using the final KE. All right, and you will find the velocity. Okay, now if I remember correctly, I think the velocity is somewhere between 10 and 20 meters per second, more or less. So that's the answer. Okay, now the next one is very similar, but in this case, it's just going straight up and it was stationary. So the work done on the system, again, I'm going to just go ahead and give you a work equals FD. You should be able to find it. And then how high is the box going to go? Well, here's the thing. This system had no kinetic or potential energy to start because this was a stationary box. So if we think of it in terms of KE plus PE plus work equals KE plus PE final, okay, I'm kind of leaving off the subscripts. Here's the thing, 0 KE plus 0 PE plus my work equals mechanical energy. Actually, I guess we could have just done it simply with mechanical energy because Ke plus Pe equals mechanical energy. I guess another easier way to think of it, well, now that works for me. So basically, here's what we have. Okay, the only energy in this system was what was done by the work. Okay, so when you think about how high, okay, hi, cat. When you think about how high this box is going to go, you have to realize that the work is your mechanical energy. Okay, and that mechanical energy is all gravitational potential energy because it's going up. So, okay, when all of that mechanical energy, you'll be able to find height that way. Okay, and finally, number 5. This one, you do it just like you did number 3. However, you are now in the opposite direction. So, your final velocity is going to be less than 12 meters per second. Okay, it's because it's in the opposite direction. All right. So that's where you're going to find that one. Okay, guys. So I'm going to stop there. I'm going to upload this so you have a little bit of help. Okay. And that's great.